All right, folks, let's do this. All right, I'm going to show you how to do this super quick today. But for right now, everybody should have the derivative of this thing here. Is 1 over 2 root x. You can have the limit whole thing going on, right? Because you're going to do... Yeah, that's fine. But, yo, guys, I'm asking you to do this here, right? You all know this.
Yes, I do. I don't like it.
It's the last time we're going to do it. Remember it fondly. You're going to do the conjugate. Right, Sale? Go, what you doing there, bud? Okay. Over here, we should have got -1 over x squared. Okay? Again, we got a bunch of examples doing that, but again, the initial setup is this. Can we handle that? All right. There's some others we can try, but we're not going to do all these. Here's what we're going to do. You ready? All right. Here we go. This is online. You can write this in your notes, okay? I'm recording this so I can drop this online for those who are not here. You ready? If f of x is equal to a times x to a power, right? We're not going to be doing the whole limit h going to 0 nonsense anymore. That, by the way, is called the definition of derivative, right, Jax?
Yes.
Nothing like looking out on my AP students and seeing cell phones everywhere. Hi. Look at them all. What do y'all do on these cell phones? Playing games. Okay, excellent. I appreciate the honesty. Here we go. You ready? This is a big day for us. The derivative of a number times x to a power can be found by following this simple pattern. You bring the exponent down, you multiply it by the coefficient, you subtract 1 off the exponent.
Yeah. It made me very frustrated.
Some of you already know this. Now you all know it. That's called the power rule. Let me throw this out there too. I'm about to drop, not today necessarily, but the next couple of days, all kinds of information on you about how to find derivatives. Think of every function you can think of in your head. We're going to learn how to derive them. It's going to require some memorization. Okay? I'm seeing on the tests and quizzes that some of us are not studying and memorizing the things I'm asking you to. If you do not get these down initially, kids, the rest of what we do is going to be very, very difficult. So when I give you homework and it just says study these rules, that means study these rules, okay? Actually get these down. It will make this class much, much more enjoyable and also make you a much more successful person in life, I imagine. Okay? Okay. Yes? Oh, excellent. Guys, this right here, f with a little apostrophe on it, that's called f prime of x, right? It's also called, you ready? Can I type this out here? Ready? It's also called the derivative, same thing. And you might even see this, of f of x with respect to x. Okay. Yes. So you can call it f prime of x. You can call it the derivative of f of x with respect to x. Another thing I'm seeing a lot of, kids, I see you're all just taking pictures of notes. Okay? No, that's fine, but you remember it a whole lot better if you write it down. Okay? I don't know how you're organizing all these pictures. I imagine I'd have a hard time doing that. But anyway, write that down, okay? There are all kinds of ways to denote the derivative, kids. We call it the instantaneous rate of change. We call it f prime. We call it the slope of the tangent line. I will write these all out for you later on. They all mean the derivative. Okay? All right. Is that Maria? What do you think she's doing out there? Maria! What is she doing? Is it not Maria? Huh? What are you doing out there? Really? Because you were standing like this. What's this stance? This is the high schooler morning stance all the time all over the school. Technology. Go back out there and knock harder.
She's trying to use her phone to open the door.
All right. So anyway, Let's see this in action. You ready? Here we go. F prime of x here, that's how you say that, would be 2x to the first, right? Multiply down the 2. You should be writing this down again. I see kids on cell phones not paying attention. I need your full attention today, kids, to get this down, because everything we do builds off of this. Goodness gracious. Yes. Oh, my Lord. Okay, good. You know what?
Wait, so that's the answer?
That's it. We learned that way back in the day when you were young. You're not a kid anymore, but some days I sit and wish I was a kid again. Yeah.
A is 1.
A in this case is 1. Hey. A in this case is a 1. You see that? It's 2 times 1. Do we all see where that came from?
Yeah.
Look. Here's what I don't want to see, kids. You ready? Sometimes kids do this. Look, this is bad. I don't even want to show you. They write equals 2x. It does not equal 2x. The derivative of it is 2x. It's an entirely new function that we brought out of the ether into existence. Okay? We created a new function. You could say that we derived it from f of x. Thus the derivative. Yes.
What's an ether?
It's like out there in like the space, man. The essence of all being. Okay? All right. Super duper easy rule. You ready? If you see a plus and minus between terms, you can derive them individually. All right? It's like 3 separate questions right here. So f prime of x is just 4x. Can we handle that? The derivative of 3x is 3. That's because, ready? If you derive 3x to the first, it becomes 3 times 1 x to the 0. But x to the 0 is just 1. You know what I'm saying? I don't want you to do all that junk. I just want you to know the derivative of a number times x is that number. In addition to that, you could also think 3x, if you graphed it, is a line. We're all aware of that, right? With a slope of 3. So its derivative, which is the slope of it, should be 3. Yeah, right? Okay. And lastly, a constant, which is just a number all by its lonesome, its derivative is 0. Cool? That's happening because, look, you can technically think of that as 4x to the 0. You don't need to, but you could. And when you derive that, you would get 0 times 4x to the negative 1. That's a 4. And that would be 0. But you don't need to do all that junk. You just know the derivative of a constant is 0. Okay? Also, think about it. If you were to graph y equals 4, right? That's a horizontal line. The slope of that would be 0. That's why that happens. Also, 4 isn't changing ever, so the derivative, which is its rate of change, would be 0. Sound good? Okay. Now, we did this one for the warm-up. Remember, we got 1 over 2 root x? Look how the power rule works in mysterious ways. You can't derive this unless it's x to a power, right? That's the same thing. If you are uncomfortable with roots and fractions, I recommend studying those and working with those. You don't want to get held up in calculus because you can't do algebra 2 or elementary school math with fractions. Okay? F prime of x, following our product or our power rule, ready, is 1/2 comes down, x to the negative 1/2. Can we handle that? A half minus 1 is negative 1/2. We all know that. Cool. So let's also notice this. I had to rewrite it first before I could derive it, right? Just because you rewrote it, that's not the derivative. It's still equal to what we started with. Okay? But we would never, ever, ever leave a negative exponent in there. Matter of fact, the only form of simplification that I want you to do in this entire unit is I do not want negative exponents. So if you have negative exponents, rewrite it so they are not there. Easy enough? Cool. I mean, fractions, obviously, like, you would reduce fractions and all that crap too, right? But other than that, I don't care about simplifying at all. Cool. And we would probably write this like this. There you go. And if I were you, I'm not, I'm me, okay? I would remember the derivative of root x is just 1 over 2 root x. Cool. You see it enough that if you just memorize that, that's a useful thing to know. All right. You don't want to have to go through all these steps. Everybody with me? You see why that is? You saw we got that when we did the warm-up the long way? Cool. Even though I didn't write all the workout. Okay? Same thing over here. This one is x to the negative 1. Right? So negative exponents, fraction exponents, all the exponent rules, that's the stuff that gives kids trouble in this little unit here. F prime of x would be negative 1, x to the negative 2nd. Are we okay with that? That's power rule. Doesn't matter if it's negative, fractions, whatever, it still works. And that would be negative 1 over x squared, which is exactly what we got. Cool. So, if we had to derive x cubed a long way, you got to cube out x plus h. It's kind of a pain. What's this derivative going to be? 3. Listen to you all doing calculus. You're so good. 3x squared. Okay? You ready? What is the purpose of this equation? It tells me the slope of the original equation. That is it. It tells me the slope of it. Okay? All right. And lastly, we got this over here. We'd have to rewrite this as x to the negative 1/2. Right? And we would use the power rule on that. So f prime of x, check this out though, we're gonna be lazy here a little bit. It's negative 1/2, right? And it should be x to the negative 3/2. But once you can think in your head x to the negative 3/2, right? Just put it down the bottom. That's where it's gonna be. X to the 3/2. Can we handle that? Questions? Comments? Okay. All right, random thoughts. In terms of style, I like to write the root for x to the 1/2, like root x. But for every other root, like cube roots and fourth roots, I'd rather have the exponent. Okay? So like x to the 3/2, I would just leave it like that. Like this, you could rewrite this as negative 1 over 2 times the square root of x cubed. That is the same thing. That might be that in like a multiple choice answer, maybe. But I think it's better to leave it like that with the power rule. Because sometimes, gasp, you might have to derive this thing twice, maybe 3 times. Okay, I know. All right. Also, if you're sloppy like I was in high school, sometimes you have like 4 times the cube root of x, and suddenly that becomes 4 times cube root of x, and then all of a sudden you're working down the page, and now you've got 4 cubed times the square root of x, and you're like, how did that happen? Okay, that doesn't happen if you use fractional exponents. Cool? You know what I'm saying? That's also why I put this little tail on my square roots usually. That denotes that it's like ending. Okay? Because some of y'all, I can see your answers. Like yesterday, we had this answer somewhere in there. You get to have that. Is that root 6x and then minus 2? Is it root 6x minus 2? You know what I mean? Like, just be neat about what you're doing. Okay? All right. Now, here's something we're going to practice. So, have fun. All right, we're back. Here we go. What's up? Okay, so I'm assuming you're all experts at deriving at this point. So you got 16x cubed minus 9x squared plus 2. Feeling good about that? Good. We got g prime of x is 25x to the 4th minus 40x. Feeling okay with that one? Yeah, super easy, right? You're like, why didn't you show us this from the beginning? And I could have, but I wanted to practice algebra skills, kids. Right? Boo, algebra. All right, h prime of x. The derivative of root x. Well, first off, you can rewrite that, right? You can think x to the 1/2 plus x to the negative 1/5, right? But the derivative of root x, I'm telling you, just memorize, it's 1 over 2 root x. Minus 1/5, right? That's what happens with the negative 1/5 coming down. Subtract 1 off of that. That's x to the negative 6/5. How we doing? Okay. And last but not least.
Oh, I know that. Wait, is it okay if we do it like the 5th root of x to the...
You can rewrite it as a root if you like, but I think using it as a exponent like that is going to be better.
Okay.
Just in most situations, but it's not incorrect to write it like that. Okay?
Wait, what? Oh, I understood it.
Huh? That's 6/5. Yeah, that's 6/5. Right? Okay. And then over here, why is this so thick? Oh, I got you on that. Let's go to thinner. There we go. Okay. This is really x to the negative second minus 5x to the negative 1 plus 4x to the negative 2/3. You got to rewrite like that so we can do the power rule or use the power rule. Okay? So k prime of x is negative 2x to the negative third, just goes down the bottom like that. Okay, no negative exponents. Plus 5x to the negative 2, just puts an x squared down the bottom. Minus 8/3. 4 times 2/3 is 8/3. X to the negative 5/3. So that puts it down here. Can we handle the power rule? Feeling good? Okay, what's wrong? We're definitely going to practice, okay? Let me show you. So look, the power rule does not get any more complicated. We're going to practice it today. I'm not going to be here tomorrow, so you are going to practice it on Delta Math tomorrow. Yeah, I know, right? Friday, we're going to practice it some more. And then guess what we're going to do Monday? Have a quiz on the power rule. Okay? It should be super easy.
Why Monday?
Yeah.
Wait,
Yes.
Monday?
Monday, yes. No, you get the whole weekend to review. Monday is a day of the week. Okay, here we go. If you go to Canvas, look at me, kids. I'm Mr. Smith. If you go to Canvas, they come to my email, man. If you go to Wednesday, which is today, you will see two things. One says derivatives 1 with an answer key. That's what we just did. You will also see derivatives 2 with an answer key. That is your homework. Okay? It's due tomorrow. Hello. The Delta Math that I'm leaving you for tomorrow is due Friday at 7 a.m. All right? There's another Delta Math on Friday that's due on Monday. So Friday we're going to learn a whole lot more derivative rules. So at this point, even though you're feeling super powerful deriving x to powers, we actually can derive all kinds of stuff, and I'm going to show you how to handle that later. But it's not time to go yet, kids. Don't pack up. I'm going to show you some more. Ready? Yeah. Just a couple power rule things here, okay? Couple more examples of power rule. Show you some things that pop up and how students kind of like mess up some rules. Okay, you ready? Here we go. If you have something like this, I'm just making that up, okay? Let's say that's y. Because that is multiplication there, right? This and this, hello, we'll make our lives simpler in here. You should think of this as 3/7 x to the 4th. Yes, you want it to be a number times x to a power. Same thing. So y prime here is just, you know what, let's go ahead and change this to like a 16 or something. Just for fun. When you derive that, you can do 4 times 3 and get 12 over 16. But you all know that 4 and 16 cancel out. That's just 3/4. So that's one thing, okay? We got that going on. Fractions work super duper nicely with multiplication. Addition, not so much. We'll talk about that later. But are we okay with that one? You can pull the x off the top and just make it a coefficient times x to a power. The same thing is true if you see something like this. If x is in that denominator and there's some numbers floating around, but it's all multiplication, that is the same thing as 2/5 x to the negative third. Okay? That's not the derivative, that's what that is. But that allows us to use the power rule, our dear friend, the power rule. And that becomes negative 6/5 x to the negative 4th, which is that. How nice is that? Yes? Well, 2/5 is 8. Yeah, just multiply the coefficient by the exponent, okay? All right. Let's get a little weirder. You ready? Sometimes the AP test likes to throw easy questions at you, but they make them look it's like a little itty bitty weird, and then you're like, what? Okay, you all know how to do this already. I don't even need to do any work for this, but let's say we had this. okay? Radicals, so all we can derive, everyone, is a number times x to a power. That's it. This is not in that format, all right? But it is multiplication in a root. So the first thing you should do here, see if you're all with me, is break apart that root. Can we handle that? Oh, let's make this like a different root. Because x squared in there doesn't make any sense. Let's make it like a cube root or something. Everybody with me on that? Breaks apart. And now I can rewrite this as 4 over the cubed root of 3 times x to the negative 2/3. That's a 3. Everybody see how that works? Okay. I'm showing you this because sometimes students want to bring that entire thing up to the top and make it to the negative 1/3 and then derive like that. Just break it apart first. Okay? If you can use a little bit of algebra rules to make things simpler for yourself, you should do that first. So then the derivative of this is just an easy negative 8 over 3 times the cubed root of 3. Can we handle that? That's the exponent coming down, being multiplied, right? X to the negative 5/3. What's that there? Is that all right? What's wrong? We're doing, so we're doing negative 2/3 times 4 over the cubed root of 3 times x to the negative 5/3. That's what's going on. What's up, Natalie? 3x to the 5th. Cubed root of 3x to the 5th. Yes, you could. But again, it's going to behoove us, okay? It will be advantageous to have the x separated from that because of the power rule. But it's not incorrect to do that. All right? Okay. Here we go. Let's keep going. You ready? Because our super strong powers are really limited, if I asked you to derive this thing, we can't derive that in the form that it currently exists. All right? However, we could rewrite it so that it's x to a power times some number. We have to FOIL it out. All right? Everybody knows, actually, not everybody knows, that something plus something squared is not the first thing squared plus the second thing squared. It doesn't work like that. It's the first thing squared. Do you all know x cubed squared is x to the 6th? That's x cubed times x cubed. Plus, double them together. That's 2x to the 4th times 2. That's the middle term when you square something out. Plus the last thing squared. That's still what f of x is. It's exactly the same as that. All right? So f prime of x would just be 6x to the 5th plus 16x cubed plus 8x. You all see how we rewrite that one? Your homework has a couple like that, okay?
Okay.
If it's things being multiplied, you got to FOIL it out first, or whatever it is, to do the, okay? You might come across, you will come across. Guys, when I say there's a quiz, I'm talking about that could be on the quiz. That's how hard the quiz is going to be. All right?
That's what the quiz is going to be?
Yeah, this could be on the quiz. You guys are going to love this. 3 times the square root of x. There we go. Yes, sir.
Quiz, which form, which field, or
What do you mean? It's going to be power rule.
Oh, no, I just said, I told you.
Oh, yeah, it's the only way you can do it right now, yeah.
No, but you can't do this.
H going to 0? No, it would be way too complicated to do H going to 0.
Well, what if you want?
You just, it would take forever to do this, man. Like, it just,
If you wanted to.
I mean, I guess, but it's a whole lot of algebra. I don't know if I could write that out like that and simplify it down. Anyway, because we want this to be number times x to power, right? That's what we need here. I'm going to distribute the 3 root x into there. Can we handle that? Yes. Do we all know that this itself is equal to 3x to the 1/2 times 2x cubed plus 2x minus 4x to the 1/3? So that's equal to, ready, 6x to the 7/2. We should be able to do that in our heads. Those are fractions. That's how they work. You know, when you multiply, you add the exponents. That's an algebra rule. Then it's going to be plus 6x to the 3/2. You're adding 3.5. That's 7/2.
Oh.
Do we agree that x to the 5th times x cubed is x to the 8th? So x to the 1/2 times x cubed is x to the, you add them together. 3 is 6/2. 6/2 plus 1/2, 7/2. Okay? Minus 12. Think about this. We have to get a common denominator here because I'm multiplying x to the 1/2 times x to the 1/3. This is just me making sure you know how to handle fractions, gang, really. 1/3 is 2/6. 1/2 is 3/6. This is x to the 5/6. You add them together, okay? Now, even though we've done some work, we haven't really derived it. We haven't derived it at all. We just rewrote it. So something I'll urge you to do too, sometimes students want to derive like half the equation and not the other half. They're like simplifying part and deriving part. That's like a weird like Frankenstein derivative function kind of mix. Don't do that, okay? When you derive everything at one time, okay? So if you're going to simplify something, don't derive anything yet, all right? But anyway, when you derive this, so this is all still g. Do we know that we get g prime is, look, multiply 7/2 times 6 is 21. Because the 6 and the 2 make a 3, okay? Plus 3/2 times 6 is 9 to the 1/2. 5/6 times negative 12 is 10. X to the negative 1/6 will be that. Whew! All I'm doing is multiplying and subtracting. What makes this appear difficult is the exponent rules and the fractions, not the calculus, okay? So that's why we're practicing that. Everybody understand what happened there? We're okay? I'm going to show you one more. Boom. It's very, very similar, but it involves division. Let's say we had 2x to the 5th minus 3x squared plus 8 root x minus 2 all over, I don't know, what do you like? 7x squared. Can we handle that? That looks complicated. But just like multiplication distributes, division distributes. This is the same exact thing as 2/7 x to the 3rd. Do we all see where that came from? That's this divided into that. Minus 3/7. That's this divided into that. Plus 8/7, but now, oh no, I have to do a half minus 2. That's negative 3/2. Okay? Minus 2/7 x to the negative 2 is how you'd rewrite that. So that's divided into here. Everybody see where this came from? I'm dividing the denominator. The division distributes. Okay? That's the same thing as taking this I'm writing the same thing, times 1 over 7x squared. It's the same thing. Okay? The exponent subtract now because I'm dividing. But anyway, you're going to do the power rule after this. So I'm not going to finish that up, but y'all can do the power rule. I have faith in you. Try your homework. I'll see you on Friday. Later, Gators.